Alright guys, welcome. We're going to get started on our properties of squares and trapezoids. So first of all this information right here is true of our parallelogram. So this is just parallelogram. So a square is a type of parallelogram, just like we saw with a rectangle and a rhombus. But a square has all the properties of all those other shapes too, rectangle and a rhombus. So it's got the four right angles and the diagonals are congruent, these pieces, straight from the rectangle. And then it's also got four congruent, that says sides, not dies. Sorry, typo. It has four congruent sides of a rhombus. The diagonals are perpendicular like a rhombus, and the diagonals bisect the opposite angles, just like a rhombus. So the square has got everything. Okay, so some people have said before, a rectangle is a square, but a square is not a rectangle, and that's because a rectangle possesses all the properties of these two and the parallelogram. So these are the parallelogram, rectangle, and rhombus, so it's got it all. So if we look at this first one, AD is 11, so all we do is go ahead and mark 11. And now I don't even look over here, I just want to fill in my picture with everything I know. And, well, I know all the sides are congruent, so I'm just going to go 11, 11, and 11. Now, it's asking me for angle measures, but they didn't give me any. Well, here's the cool thing. A square has all the same angle measures, no matter what size it is. Okay. The reason why, we could talk about similarity. We have all of the congruent sides, just like we did with the triangle. Just like an equilateral triangle all has 60-degree angles. We know these are 90, we know they get bisected, so all these interior angles in here are going to be 45 and 45. So that's all of these, 45, 45 every single time. And we know that the diagonals are perpendicular, so we get 90, 90, 90. So basically what I've just created here is 4 45, 45, 90 special right triangles, which is pretty neat. So when I look over here and filling this stuff out, it should be pretty easy. So DAB is the whole angle, 90. This is really 90 or 45 basically. AEB, that's this angle in here, that's 90. CBD, that's the little angle up here, 45. And BAC, the little angle up here, is 45. Now BC, 11. These are all sideways, so I'll switch my color. AC, now AC is this piece, but if we look at it, not only do we have four little 45, 45, 90s, but we also have a big 45, 45, 90 this way. And so if I was using L rad 2, AC, I could use Pythagorean theorem, but AC is just going to be L rad 2, or in this case 11 rad 2. BD, same thing, we have a 45, 45, 90 right here, so that's also 11 rad 2. And then EC, which is half of it, we could do as 11 rad 2 divided by 2. And again, we could get into decimals if we want on that, but hey, why not keep it nice and easy? So there you go. That's a square. This one right here, pretty simple. We're not going to go through all of these, but it's pointing this angle. Doesn't matter we have any information. We know all these little pieces are 45. So that one we've just set equal to 45. And solve if you like. And this one, we have SW here, which SW is this little piece right here. And we have WU, which is this piece right here. Well, since this actually shares what we know about a parallelogram, that our diagonals bisect each other, we would just simply have to set those equal to each other. And then once we find x, we can plug it back in to find the whole thing, and BT is going to be the same because the diagonals are also congruent, like in a rectangle. Alright, moving down, coordinate geometry. So we've been talking about, if I gave you 4 vertices, could you figure out which shape this is? And now we've come to our final shape out of these 4 parallelogram type shapes, which we have. So step 1 is find the distance of sides, and then distance of diagonals. And with those two things, okay, again, that's going to be four sides, unfortunately, and that's going to be, 2 diagonals. So if you have to do distance formula 6 times, if it's messy, you should be able to figure these out pretty quickly. And so what we want to do is case 1, opposite sides are congruent, but diagonals are not. This is going to be our parallelogram, our most basic shape. Opposite sides are congruent and diagonals are congruent. That would be my rectangle. Case 3, all four sides are congruent and diagonals are not congruent. That would be the rhombus. And then last but not least, all sides are congruent, all diagonals are congruent. That would be the square. Okay? So there it is. As long as we can do distance formula, and again, there are some shorter cut ways of doing that when we have a coordinate plane, but we can figure those out. Now this side right here, I would like you to do one of these on your own. We'll check it in class, but you should know how to do distance formula and try and figure out what it is. So do that on your own. Let's move down here. Our final shape, this is our fifth quadrilateral. It's not a parallelogram, but it is a quadrilateral, meaning it has four sides. And so we have two main types, and these are trapezoids. So we have non-isosceles and isosceles. So a basic trapezoid is one pair of opposite sides are parallel. This cannot be a parallelogram because a parallelogram has two. So that doesn't work. But since we do have opposite sides are parallel, consecutive angles between the parallel lines are supplementary. So if we called this angle 1 and angle 2, we know that 1 and 2 would add to 180. And then if we did 3 and 4, we know angle 3 plus angle 4 would add to 180. Okay? 1 and 4 would not add to 180 because they're not on parallels, but these are, oh my gosh, sorry, 1 and 4 would not because these aren't parallel, so those are same side interior, but they're not on parallel, so they're not going to add to 180. Those are same side interior on parallel, so they add to 180. Those are same side interior that are on parallel, so those add to 180. Then the more commonly one is our isosceles trapezoids. They have the same properties of non-isosceles trapezoids, so they still have like the 1, 2, and 3, 4 would be the same, so we can label those. 1 and 2 are going to add up to 180. 3 and 4 are going to add up to 180. Diagonals are congruent. Base angles are congruent. So not only that, but we know that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. It does have two sets of base angles here. And opposite angles are supplementary. So 1 and 3 and 2 and 4 are going to add to 180. So angle 1 plus angle 3 add to 180. And angle 2 and angle 4 add to 180. So a lot going on in this one. So let's go ahead and apply some of these rules. So first and foremost, this is not an isosceles. This is a basic one. But we can find our other angles because we know these two are going to add up to 180. And we know these two are going to add up to 180. And so we simply just go ahead and do the math real quick. 180 minus 51, that gives me 129 for K. And we have 180 minus 87, and we get 93 for M. So pretty easy. Same thing over here. We're just going to add those two up, set equal to 180. We won't do the whole math there, but we know that they're going to be supplementary. So add them up, set them equal to 180, solve for x, and we can substitute it back in for r. Now we get to the isosceles trapezoid. This is one we want to spend more time on. We have MP. MP is this piece right here, 16x minus 13. NO, 9x plus 8. And then we have PN, which is the diagonal here. So I'm just going to go ahead and do this. And that's 5y plus 19. And then MO, which is the other diagonal. I'll use blue. That will look different. And that is 12y minus 37. So we want to solve for x and y. And, well, if it's an isosceles, we know these two sides are congruent. And if they're congruent, they should be set equal to each other. And these two are diagonals. We know that the diagonals are congruent, so those should also be set equal to each other. So you're basically just setting them equal to and solving for x and y, which is relatively easy. We'll just do that real quick. Subtract the 9x over here. We're going to get 7x. Add the 13 over there. We should get 21. X equals 3. And this side over here, I'm going to subtract the 5y from here. I should get 7y. I'm going to do 37 plus 19, which gives me 56, and then divide by 7, we should get y equals 8. Okay? So there we go. Nice and easy. As we move down these, I'm just going to set these up real quickly. Base angles are congruent. So 2x plus 27 equals 5x minus 12. Solve, plug back in. Pretty simple. Opposite angles are supplementary, so this one we can take 10x plus 5. And we could really write that 10x plus 5 is this angle here, and then do supplementary again, but we can just straight up go for it. So we add them, set it equal to 180. Alright, last thing. Mid-segment of a trapezoid connects the midpoints of the legs. So if we have these little midpoints of the legs, if EF is the mid-segment of a trapezoid ABC, then what is true? Well, we end up with a pretty cool little thing that happens here. I like to think is EF is the average of AB and DC. So written out, I think that's kind of makes sense, but if we were to write it out as an equation, it would really be EF is equal to AB plus DC divided by 2. And that's kind of what an average is. So we can solve these equations by doing that, so I'll do one right here. So we take this guy and this guy, right? The little guy, the big guy. If we add them together, divide by 2, I should get this piece right here. So in written form, that'd be LM equals GH plus KJ divided by 2. And when we input that in, we should get 25 equals, and GH is going to be 2x plus 11 plus 6x minus 1, and the whole thing's divided by 2. Now, instead of dividing this all by 2, I'm just going to go ahead and multiply the 2 out right away. So I end up with 50 over here. Combine like terms, 2x and 6x is 8x plus 10. I'm going to subtract the 10 to get 40 equals 8x. Boy, that is going to be very convenient for us because that will divide in nicely to give me x equals 5. Now it does say find kj, so I'm not quite done yet, so I got to go plug it back into kj. That's 6 times 5 minus 1, and that is 30 minus 1, which is 29. So kj is equal to 29. And that's it. Thank you very much. Just trying to make the video longer so they have to sit and watch through it because something might happen later, you know what I mean? It's pretty smart. I could just solve a Rubik's Cube on here. Let's see.
Maybe they'll find out that I was actually here the entire time.
You were never here. It's all a mystery. If I zoom out, it'll be easier to see me solve this. Do you think they're going to stay and watch the rest of the video?
I don't know, but what I do know is that according to all laws, all known laws of aviation, a bumblebee should not be able to fly.
That's crazy. But it does. So maybe the laws of aviation aren't very good.
Maybe we don't know everything.
Well, I know I don't know anything, so that's why I have one leg up on the competition. Alright, got the top side done. Now to do the corners. I feel like I should go slow on this, you know, so they can really learn how to do it.
No, you should go really fast.
Yeah, but then I'll mess up. Okay, I got all the bottom 2 layers, now the top. Cross, let's see. We're almost there. Okay, so I got the cross all in the right spot. Now corners. Let's see, do I have any nice corners? That's a nice corner. Am I all in? No, you're not in. Oh, oh, oh. Oh, this one's... Thank you for stopping by. Oh, yeah, it's solved. Trust me. Trust me.